Good morning, students. Continue the problems on the properties of determinants. Some 3 or more problems will be there in the classes. So first we'll prove that determinant of a plus b plus c, 2a, 3a plus 2b, 4a plus 3b plus 2c, 3a, 6a plus 3b, 10a plus 6b plus 3c. It will be equal to a cube. Now again considering the values of elements of delta. Delta is equal to a plus b plus c, 2a, 3a plus 2b, 4a plus 3b plus 2c. Then 3a, 6a plus 3b, 10a plus 6b plus 3c. Now first we'll check whether if you have any common factor for any one of the rows or in any one of the columns. Now a, 2a, 3. Just a is one of the common factor. But after that common factors, elements of first columns is nothing but 1, 2, 3. Again some elements will be different forms. But in the last problems, if any one of the common factors can be taken as in the outside, in their place of remaining elements is nothing but 1, 1, 1. But in these terms of 1, 1, 1 is possible to get easily, can be written as 0. But in these cases, so except a, so elements are nothing but 1, 2, 3. Again, some elements are in the form of different forms. Therefore, it's not possible to get any common factor for the elements of the first column. But in the second and third columns are again does not containing any common factor. Therefore, by using in their operation, R2 can be written as, now get subtraction of corresponding elements of any rows or any columns if it is possible to get 0 of some of the elements of the determinants. So ನೀವು ಯಾವ್ದಾದ್ರು ರೋ ಅಥವಾ ಕಾಲಮ್ನ ಆಪರೇಟ್ ಮಾಡಿದಾಗ ಯಾವುದಾದ್ರೂ ಎಲಿಮೆಂಟ್ಸ್ಗಳು 0 ಮಾಡಲಿಕ್ಕಾಗತ್ತಾ ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಇನ್ ದಿ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್, so 2a get subtracting with the corresponding elements of the first row. 2a minus a is nothing but a, but it's not equal to 0. Suppose if the first element is also nothing but 2a, after that subtraction 2a minus 2a is called as 0. Therefore R2 can be changes with R2 minus 2 times of R1. Elements of R1s are multiplied by 2 and these elements are subtracting with the corresponding elements of R2. Similarly, now R3 can be changes with elements of R3 are again comparing with their elements of the first row. R3 is comparing with the first row. Again these two are subtracting with each other, but 3a minus a is nothing but 2a. It's not equal to 0. Again it's a multiple of 3. If the elements of the first row is a multiple of 3, 3a minus 3a is nothing but 0. Then R3 can be written as R3 minus 3 times of R1. So therefore elements are first row a plus b plus c. Elements of first rows are does not alter. But if their elements of the second row can be operated, that is R2 minus 2 times of R1. What are the elements of R1 are multiplied by 2 and subtracting with the corresponding elements of R2. First one is 2a minus 2a is nothing but 0. In the second element, first we'll write their elements of R2. Otherwise we'll just simplify it in the side, outside of. So R2 minus 2 times of R1. So R2 is nothing but 3a minus plus 2b. 3a plus 2b minus 2 times of R1. 2 times of R1 is nothing but 2a plus 2b. After subtraction, 3a minus 2a is a. 2b are get cancelled. Therefore, R2 minus 2 times of R1 is a. Similarly, second element, R2 is nothing but 4a plus 3b plus 2c minus 2 times of corresponding R1 is 2a plus 2b plus 2c. Again get subtracting. 4a minus 2a is nothing but 2a. 3b minus 2b is nothing but plus b and plus 2c minus 2c are get cancelled. Therefore the third element is 2a plus b. Similarly, now R3 can be changes with R3 minus 3 times of R1. Again elements of R1 are multiplied by 3 and get subtracting with the corresponding elements of R3. 3a minus 3a is nothing but 0. And the second element R3 minus 3 times of R1, where R3 is 6a plus 3b minus 3 times of R1 is nothing but 3a plus 3b. Again plus 3b minus 3b are get cancelled. 6a minus 3a is nothing but 3a. And the last element R3 is 10a plus 6b plus 3c minus of 3 times of R1 is nothing but 3a plus 3b plus 3c. Again plus 3c minus 3c are get cancelled. 10a minus 3a is nothing but 7a, and then 6b minus 3b is nothing but plus 3b. That is an elements of R2 minus 2 times of R1 and R3 minus 3 times of R1. So the first two elements of the first columns are nothing but 0. So after then we will observe the elements of second elements of R3. Suppose that element is also nothing but 0, after then by using the properties of the determinant. Therefore, if it is possible to get written as 0, now R3 can be changed with R3 minus. Now if it is comparing with the elements of second row. So if elements of second row is nothing but a, 3a minus a is not equal to 0. Suppose if it is also nothing but 3a, 3a minus 3a is called as 0. So therefore R3 can be changes with R3 minus 3 times of R2. So R3 can be changes with R3 minus 3 times of R2. Then so delta is nothing but elements of the first row a plus b, a plus b plus c, and the second row 0, a, 2a plus b. But in the elements of the third row are get subtracting with the corresponding elements of 3 times of the second row. R3 minus 3 times of R2. Now first element R3 is 0 minus 3 times of R2 is also 0. Therefore 0 minus 0 is 0. Then second element R3 is 3a minus 3 times of corresponding R2 is a. Again 3a minus 3a is nothing but 0. Then third element R3 is 7a plus 3b minus 3 times of corresponding elements of second row. 3 into 2a is 6a plus 3 into b is 3b. So after that plus 3b minus 3b are get cancelled. 7a minus 6a is nothing but a. Then by using the properties of the determinant, if one sides of the diagonal elements are will be 0, then the values of the determinant is the product of the principal diagonal elements. Now what are the elements of the principal diagonal elements? A. Then their product is nothing but a cube, that is the solutions are in the RHS. Next one, prove that determinant of b plus c, a, b, c plus a, b, c a plus b equal to 4abc. Now delta is nothing but b plus c, a, b, c plus a, b, c a plus b. Now again, first we'll check whether what are the common elements of any rows or in any columns. In the first one is distribution form b plus c. Therefore, it does not containing any common factor. So, in the second and third elements are nothing but a. But in the first elements are not in the terms of a. Similarly, in these two are become same. But in the second element is does not containing for b. Similarly for the third row. So therefore, if it is not possible to get a common factor. So now, by using the either addition or subtractions of the corresponding elements of any rows or columns. Now if it is become sum of the elements of the determinants are will be 0. So therefore, first we'll observe this element b plus c, b, c. Suppose get subtraction of these elements, plus b minus b, plus c minus c are possible to get cancelled. So similarly, plus a minus a, plus c minus c. So now it changes, sum of their elements of in the determinants are nothing but 0. So therefore R1 can be changes with R1 minus R2 minus R3. So will be observed in any one of these elements. So not all the elements are at a time will be 0. Therefore first we'll check whether one of the elements, at least one of the elements are will be 0. Now first we'll comparing in the first element, b plus c minus b is get cancelled, c minus c are get cancelled. Therefore the first elements of that determinant will be 0. Therefore R1 can be changes with R1 minus R2 minus R3. Then delta R1 is b plus c minus R2 is minus b minus R3 is minus c. Similar. Second element R1 is a minus R2 is c minus a minus R3 is minus c. Third element. So R1 is a minus R2 is minus b minus R3 is minus a minus b. And elements of second and third rows are nothing but changes. C, A plus B. So after that, plus B minus B and plus C minus C are get cancelled. Therefore, if all the elements of the first rows are get cancelled, and in the second element, minus A plus A are get cancelled, and these are also plus A minus A are get cancelled. Then the remaining elements of delta is nothing but, in the first element is 0, B, C. Elements of the first column. First elements are get cancelled, that is 0, B, C. In the second column 6, minus C is nothing but minus 2C, C plus A, C. And third element is minus 2B, B, A plus B. So after that, if it is again some of their elements are possible to get 0, plus C minus C is possible to get 0. Therefore, C2 can be changes with C2 minus C3, sorry, C1. C2 minus C1. Again, C3 can be changes with C3 minus C1. These elements are also nothing but 0. C3 can be changes with C3 minus C1. Therefore, elements of the first columns are 0, B, C. Elements of the second column, C2 minus C1. Corresponding elements of the second column are get subtracting with their elements of the first column. Minus 2C minus 0 is nothing but minus 2C. And then second element, C plus A minus B. C plus A minus B. Third element is nothing but 0. Again, C3 can be changes with C3 minus C1. Corresponding element of C3 and C1 are get subtracting with each other. Minus 2B minus 0 is nothing but minus 2B. B minus B is 0. A plus B minus C. So after then, by using their expansion form, get an alternating sign and simplify the values of the determinant. Now, the first element is 0. So, if 0 is an element of the first row and first column, these elements are get neglected. Remainings are nothing but A plus C minus B, A plus B minus C. C plus A minus B into A plus B minus C. And right diagonal will be 0. And second element, minus into minus is plus 2C. 2C is an element of the first row, second column, and these are get neglected and remainings are get multiplied. B into A is AB plus B into B is nothing but B square plus B into minus C is minus BC. Again, in the right diagonals are will be 0. Right diagonals are 0. Then the last element is minus 2B of. So minus 2B of left diagonal r will be 0, left diagonal is 0, minus right diagonal, c into c is c square, c into a is ac, c into minus bc. So then we'll get simplified in the form of now the first element is 0 into, the first element is nothing but 0 into anything will be 0, therefore that element is get neglected, all element will be 0. But in the second element 2c into a is nothing but 2cab, 2c can be distribute in all the elements of that expansion, 2c into ab is 2abc plus 2c into b square is nothing but 2cb square minus 2c into bc is nothing but 2bc square. That is the product of the first elements are multiplied by 2c. Similarly, the last pair minus 2b is multiplied with, so minus 2b of, so minus into minus is plus 2b into c square is 2bc square, 2b into ac is 2abc, 2b into bc is 2b square c. That is the expansion of the last group. After that, get simplify. 2bca and 2abc. Now these pairs are will be equal to each other. After these two are get adding with each other is nothing but 4abc. And the next term 2cb square, 2cb square. So last one is nothing but minus. That is minus 2cb square. Both are get cancelled. And the last element minus 2bc square minus 2b square is also get cancelled. Therefore, the delta is nothing but minus 4abc. So that is the solution of the RHS. Next one. Prove that determinant of 1 plus a 1 1, 1 1 plus b 1, 1 1 1 plus c equal to abc of 1 plus 1 by a 1 by b plus 1 by c. Otherwise it also can be written as in the form of abc plus bc plus ca plus a. So both are will be depends on, in their given result is depends on both of them. Suppose if it is in the form of abc plus bc plus ca plus ab, after simplification is nothing in the form of abc of 1 plus 1 by a plus 1 by b plus 1 by c. Now first we will consider the delta. 1 plus a 1 1, 1 1 plus b 1, 1 1 1 plus c. Now again we will observe if all the elements of any rows or any columns are does not containing even any common factor. Therefore, if it is possible to get sum of the elements of the determinants are nothing but 0 after by using either addition or then subtractions of the corresponding elements by using the procedure for the last problems. So therefore, first we will observe this element. After the subtractions of these two elements are nothing but 0. Therefore, R3 can be changes with R3 minus R1. Similarly, R2 minus R1 is also nothing but 0. So therefore, R2 can be changes with R2 minus R1 and R3 can be changes with R3 minus R1. So then, first row 1 plus A 1 1 and the second row. So R2 minus R1, 1 minus of 1 plus A plus 1 minus 1 R get cancel is nothing but minus A. Similarly, 1 plus B minus B, 1 1 get cancel is plus B. And the last element plus 1 minus 1 R will be 0. Similarly, R3 can be changes with R3 minus R1. 1 minus of 1 plus A is nothing but again minus A. 1 minus 1 is 0. Third element is 1 plus C minus 1 is nothing but C. Now, these two elements are will be 0. Again, now if it is also possible to get 0 after subtraction of C3 minus C2. ಸೊ C3 ಮೈನಸ್ C2 ಮಾಡಿದಾಗ ಈ ಒಂದು ಎಲಿಮೆಂಟನ್ನು ನಾನು 0 ಮಾಡೋ ಅಂಥ ಪಾಸಿಬಿಲಿಟೀಸ್ ಇರುತ್ತೆ. ಸೊ ದೇರ್ಫೋರ್ R3 ಕ್ಯಾನ್ ಬಿ ಚೇಂಜಸ್ ವಿತ್ C3 ಕ್ಯಾನ್ ಬಿ ಚೇಂಜಸ್ ವಿತ್ C3 ಮೈನಸ್ C2. ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ ಫಸ್ಟ್ ಕಾಲಮ್ 1 ಪ್ಲಸ್ A ಮೈನಸ್ A ಮೈನಸ್ A 1 B 0 and C3 can be changes with there is not necessity because after that 0 is nothing but changes. ಸೊ ನಮಗೆ ಅಲ್ಲಿ 0 ಆಗಿರೋಂಥ ಎಲಿಮೆಂಟ್ಸು ಮತ್ತೆ ಚೇಂಜಸ್ ಅಂತ ಆಗುತ್ತೆ ನೋಡಿ. 0 ಮೈನಸ್ ಮಾಡಿದಾಗ 0 ಪ್ಲಸಸ್ಸಲ್ಲಿ ಮತ್ತು ಸಮ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ವಿಲ್ ಬಿ ರಿಪ್ಲೇಸ್. ದೇರ್ಫೋರ್ ಇಫ್ ಇಟ್ ಇಸ್ ನಾಟ್ ನೆಸಸರಿ, ಸೊ ಬೈ ಯೂಸಿಂಗ್ ಇನ್ ಎನ್ ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಸೆಟ್, ಬೈ ಯೂಸಿಂಗ್ ಇನ್ ದ ಎಕ್ಸ್ಪಾನ್ಷನ್ ಫಾರ್ಮ್ get simplify. The first element is 1 plus A of. So 1 plus A is an element of the first row and first column, and these elements are get neglected and the remaining elements are B into C. Left diagonal is B into C, right diagonal is 0. Similarly 1. So 1 is an element of the first row, second column. These elements are get neglected and the remaining elements are nothing but minus A into C, and the right diagonals are will be 0. Then third element is 1. So 1 is an element of the first row, third column. These are get neglected and remaining are get cross multiply. Minus A into 0 is 0. Right diagonal is minus A into B. Minus into minus is plus A into B. So get simplify. In the distribution of 1 plus A into BC. 1 into BC is nothing but BC. Plus A into BC is ABC. Minus into minus is plus 1 into AC is AC. Plus 1 into AB is AB. Now first we'll observe that result. It's a one of the result for the given proof. ABC plus BC plus AC plus A. So after that, in that expansion, one of ABC as a common factor. In the whole expansion, ABC as a common factor. Therefore, after common factor in place of ABC is nothing but 1. Plus in terms of BC. Now ABC as a common factor, whatever the remaining elements in terms of BC, that is 1 divided by A. Similarly, so A into C. After ABC as a common factor in these terms, 1 over B as the remaining factor. Plus again AB as a common ABC as a common factor in terms of AB, that is 1 divided by C. Therefore ABC of 1 plus 1 by A plus 1 by P plus 1 by C, that is another one of the result are in the RHS. Next one, prove that 1 plus x into y into z is equal to 0 if x, y, z are will be different and delta is equal to determinant of 1 x square 1 plus x cube 1 y square 1 plus y cube and 1 z square z 1 plus z cube is equal to 0. It is one of the different question from compared to previous problems. So by using the values of delta, now to prove that one of the condition is 1 plus x into y into z is equal to 0. So first we'll get simplify the what are the given elements of the delta is also by using in the RHS. It's not a proof result. So by using that condition, both LHS and RHS are will be using in a given terms. Now to prove that 1 plus x into y into z equal to 0. Now first we'll how to simplify the terms of determinant. Now we'll observe the all the elements of the third column. It's a sum of two elements, 1 plus x cube, 1 plus y cube and 1 plus z cube. So therefore one of the properties of determinant may be seventh properties of the seventh or sixth properties of the determinant. If all the elements of any row or any column is a sum of two elements, then the expression can be written as sum of two determinants. So if all the elements of any row or any column is a sum of two elements, then the whole expression can be written as sum of two determinants. It's one of the properties of the determinant. So by using the determinants, now can we expand the elements of the given delta in terms of two determinants and it will be equal to 0. 0 is one of the given condition. Now what are the elements can be expanded into these two determinants? First will first and second columns are does not alter because these are not in the form of either addition or then subtractions of two elements. ಸೊ ಸಿಕ್ಸ್ತ್ ಪ್ರಾಪರ್ಟಿ ಪ್ರಕಾರ ಯಾವ್ಯಾವ ಎಲಿಮೆಂಟ್ಸು ಅಡಿಷನಲ್ ಇರುತ್ತೆ ಅದು ಮಾತ್ರ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಫಸ್ಟ್ ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ ಕಾಲಮ್ ಎಲಿಮೆಂಟ್ಸ್ ಏನಿದೆ ಅದನ್ನು ಆ್ಯಸ್ ಇಟ್ ಈಸ್ ಎರಡೂ ಡಿಟರ್ಮಿನೆಂಟ್ಸಲ್ಲಿ ಯೂಸ್ ಮಾಡಿ. ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ವೈ ಸ್ಕ್ವೇರ್ ಝಡ್ ಸ್ಕ್ವೇರ್ ಆ್ಯಂಡ್ ಎಕ್ಸ್ ವೈ ಝಡ್ x square y square z square. But in the elements of the third columns can be distributed. So what are the first place of their elements are nothing but one of the elements in the first determinant, and the second place of their element is the elements of the second determinant, x cube y cube z. So that is one of the sixth properties of the determinant. Means if all the elements of any row or in any column is a sum of two terms, then their expression can be written as sum of two determinants. So after that, determinants can be simplified in the form of. So first will the first determinant can be continuing in the same form, just only simplify in the second determinant. So first determinants method ನಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ. So if all the elements of any one of the rows or any one of the columns is nothing but 1 1 1, get subtracting in the corresponding elements of either in row wise or in the column. These are the elements of the column wise, therefore if it is possible to get subtracting in the row wise, that method is already known that. But in that problems just will return as in these elements are in the same form, some of their steps. So first will get simplify in the second it. ಸೊ ಈಗ ಫಸ್ಟ್ ಡಿಟರ್ಮೆಂಟ್ ನಾನು ಸದ್ಯಕ್ಕೆ ಹಾಗೆ ಕಂಟಿನ್ಯೂ ಮಾಡಿ ಸೆಕೆಂಡ್ ಡಿಟರ್ಮೆಂಟಲ್ಲಿ ಏನೇನು ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡ್ಬೋದು ಫಸ್ಟ್ ವಿಲ್ ಚೆಕ್ ವೆದರ್. ನಾ ದೀಸ್ ಆರ್ ದಿ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಇನ್ ದಿ ಫಾರ್ಮ್ ಆಫ್ ಎಕ್ಸ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಎಕ್ಸ್ ಕ್ಯೂಬ್ ವೈ ಸ್ಕ್ವೇರ್ ವೈ ಕ್ಯೂಬ್ ಝಡ್ ಝಡ್ ಸ್ಕ್ವೇರ್ ಝಡ್. Now if all the elements of the first row is a multiple of x, similarly for the second row is a multiple of y, and third row is a multiple of z. Therefore in terms of x, y, z have a common factor. So in the first row r1 get a common factor by x, r2 is by y, and r3 by z. So in the first row x has a common factor, second row y has a common factor, and third row now z has a common factor. But what are the elements of the first determinants are always nothing but same. X square 1, y square 1, and z square 1. But in the second determinant, if x has a common factor, but what about the remaining 1x square? Similarly in the second row, y has a common factor, that is 1y square, and in the third row 1z square. It will be equal to 0. Then we'll observe the elements of these two determinants. So correctly observe the elements of these two determinants. See, if all the elements of the determinants are will be same but different places, different placement. So values alla ade ide, but number of placement enide interchanges ಆಗ್ತಾ ಇದೆ. So first we'll observe the elements of 1 1 1. So 1 1 1 are the elements of the third column in the first determinant, but of the same elements are represented in the first columns of the second determinant. So ಇಲ್ಲಿ third column ಅಲ್ಲಿ ಬಂದಿದೆ, ಇಲ್ಲಿ first columns ಗೆ changes ಆಗಿದೆ. Similarly x y z are the elements of the first column in the first determinant, but again x y z is the elements of the second column in the second determinant. So therefore these are get comparing with each other. If it is possible, first determinant is get converted into the form of second one, or second one is possible to get converted into the form of first one. So if any one of them is comparing with each other, if it is possible to replace your elements of the columns are in the elements of the row, it's one of the properties of the determinant. If all the elements of any two rows or any two columns are possible to interchange if the values of the determinant is changes with the sign. That is the second properties of the determinant. Second properties of the determinant, R1 and R2 are is interchange, otherwise C1 and C2 are will be interchange, then the values of the determinant is changes with their sign. Values of the determinant is changes with the sign. Now first determinant can be comparing with the second one, get be changes in the corresponding columns. ಯಾವ ಕಾಲಮ್ ಯಾವ ಪ್ಲೇಸಸ್ಗೆ ಬರಬೇಕು ಫಸ್ಟು ಡಿಟರ್ಮೆಂಟ್ನ ಸೆಕೆಂಡ್ ಜೊತೆ ಕಂಪೇರ್ ಮಾಡ್ತಾ ಹೋಗಿ, ಯಾವುದಾದ್ರೂ ಪ್ಲೇಸಸ್ ಬರಬೇಕು ಅದಕ್ಕೆ ಅದನ್ನು ಫಿಕ್ಸ್ ಮಾಡ್ತಾ ಹೋಗಿ. ಸೊ ಫಸ್ಟ್ ವಿಲ್ 1 1 1. ಸೊ 1 1 ಆರ್ ದಿ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ ದಿ ಫಸ್ಟ್ ಕಾಲಮ್ ಇನ್ ದ ಸೆಕೆಂಡ್ ಡಿಟರ್ಮೆಂಟ್, ಬಟ್ ಇನ್ ದ ಫಸ್ಟ್ ಡಿಟರ್ಮೆಂಟ್ ದರ್ ಪ್ಲೇಸ್ಮೆಂಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಥರ್ಡ್ ಕಾಲಮ್. ಸೊ ಈಗ ಥರ್ಡ್ ಕಾಲಮಿಂದ ಯಾವ ಕಾಲಮಿಗೆ ಚೇಂಜಸ್ ಆಗಬೇಕು ನನಗದು ಫಸ್ಟ್ ಕಾಲಮ್ಗೆ. Therefore C1 and C3 are interchanged. Elements of C1 and C3 are interchanged by using the second property. So if all the elements of any two rows or any two columns are interchanged, then the values of the determinant are changes with the sign. Therefore we'll put one of the negative sign in the first determinant. So what are the elements of the first column and third columns are will be interchange. Elements of third columns are nothing but in the first column, and first columns are nothing but in the third column. But if the second places are does not alter, second places are does not alter, plus in the second determinants are will be continuing in the same form. X y z of 1 1 1, x y z, x square, y square and z square. It will be equal to 0. Then so again once we'll comparing, first column is equal to second column, but again comparing with the second and third columns. So x y z are in their elements of the third column in the first determinant, but if these are in their elements of the second column in the second determinant, therefore again we'll interchange second and third column. C2 and C3 are will be interchanged. So again if any two rows or any two columns are interchanged, then the values of the determinant are changes with the sign. So after that minus into minus, minus into minus, elements of first columns are does not alter, but second and third columns are will be interchanged. Elements of second columns are x y z and third columns is x square y square z square, plus second determinant is x y z of 1 1 1, x y z, x square, y square, z square, it will be equal to 0. So after that minus into minus is nothing but plus. Then now these are in the form of determinant plus x y z of same determinant. Therefore these two are in the form of x y plus x is equal to 0. What are in place of x is nothing but sum of the determinant. So therefore the given equations are in the form of xy plus x equal to 0. After now if it is possible to get a common factor on x. So after that is nothing but 1 plus y is equal to 0. So similarly, so that is in the form of x plus x into y is equal to 0. Now one of the x has a common factor. Therefore in place of x is nothing but sum of the determinant. 1 x, x square, 1 y, y square, 1 z, z square. It's one of the common factor. What about the remaining? So if the whole determinant has a common factor, then the remaining place is nothing but 1. Plus in the second term again all determinant has a common factor, remaining is nothing but x into y into z. It will be equal to 0. Now again these two are in the form of, it's a whole determinant is a one of the element. Again 1 plus x into y into z is another one of the element. Now these two are in the form of product of two terms is equal to 0. Means x into y is equal to 0. This implies x into y equal to 0. This implies either x equal to 0 or y is equal to 0. Either x is equal to 0 or y is equal to 0. Therefore, either x means in place of x is nothing but sum of the determinants. 1 1 1, x y z, x square y square, z square is equal to 0, or either x equal to 0 or y equal to 0. Therefore in place of y is nothing but 1 plus x y z is equal to 0. But in the first determinant is not equal to 0, because it's one of the problems we'll already done in the 4 mark question. 1a square, 1b b square, 1c c square is equal to in the form of a minus b, b minus c and then c minus c. Therefore the elements of that, so values of the determinant is not equal to 0, because the solutions are in the form of x minus y, y minus z. z minus x. Therefore, such an element is get neglected. But either one of them will be 0 means first element is not equal to 0. Therefore, the second element is must understood it will be equal to c. So, therefore, 1 plus x into y into z is equal to 0. It's one of the proof of the given result. So, 1 plus x y z equal to 0.